what we have now is we say, I ask myself what value plus 3 will give me 5. And once again, we have this concept of a scale, like we've said in our previous videos. The ones that I started with the introduction of equations tells us that our left-hand side must always be equal to our right-hand side. So it is a scale that if I add a certain weight on my left-hand side is going to be heavier than my right-hand side. Therefore, I must always keep equilibrium. If I have something and I add 3 to it, it should be 5. So 5 is equal to 5, which means this left-hand side is equal to 5. And with that being said, I've already got a 3, so therefore I will say it is 2, because that will equal 5. And what do I get? X is equal to 2. So we can quickly fly through these. Number B, let's look at number B. Number B says A minus 5 is equal to 3. So I have something, subtract 5 and I only have 3 left. Another way of looking at this is not to just view my left-hand side equal to my right-hand side, which we should always do, but to implement the opposite operation. Now, fancy word for opposite is inverse. So my inverse operation always takes the opposite action of what is given. If A take away 5 gives me 3, then surely 3 plus 5 must give me A again. So A is considered to be 3 plus 5, and A, therefore, is equal to 8. So if you read through your pages yesterday, your class didn't have maths, so this is your first class for the week for maths. But if you read through the introductory pages in your Mind Action series, you'll see that according to the introduction for this chapter, just comfortably read through the concepts explained here. There we go. Chapter 7, we're literally just touching the basis of this, and you'll see here that a number sentence that is true for left-hand side being equal to right-hand side is therefore considered to be an equation. So this equation is a balancing act, the whole time equilibrium, and has to be maintained. And we then say by inspection is when we just view the sum and we see what do we have. And here with your solutions, we indicate that there's a very important symbol here, therefore, 3 little dots, therefore, which refers to us saying not another equal sign, but only maintaining one equal sign in the middle of the equation. Very important. So please just read through those pages and then you'll understand why I am stressing the importance of that equal sign and stressing the importance of using this therefore. The therefore that we have here, okay? Right, so we're just looking at what we have, what do we take away to get our right-hand side. And our next sum there is C. And according to C, K minus 9 is equal to 0. So I ask myself, what? Take away 9 will give me 0. And I need to have this side also equal to 0. So what do I get? Therefore, K is equal to 9. Number D. So when we work with our positive values, it's actually quite easy. But it's those negatives that come in, and then we worry a bit. Now we have 3 minus T gives us a negative 1. For my answer here to be a negative value, very important aspect that we learned in our first term, we need to think about starting with a positive value of 3, right? But we end with a negative value, which means we should move to the left-hand side. We are getting more negative, okay? So for 3 minus 3, that will be 0. But let's take 3 minus 4, one more, and I'll be one position less than 0, which is in fact -1. So this is by inspection. We can say, therefore, t is equal to 4. Because of this minus sign that's already present, t only takes the value of 4. Okay, let's look at number E. Number E says -4 minus x is equal to -5. Now again, we can consider we have a value, we take away another value, we're left with a value. Or you can try and use the inverse operation. If -4 minus x gives me -5, how am I going to do the complete opposite of that? If I start with a negative value of -4 and I subtract something here and I end up with -5, I ask myself, from -5 to -4, what happened? So if I'm going this way, I'm becoming a slight tad bit less negative. If I'm going that way, I'm becoming more negative to end up with -5, which means I should take 1 away. Because always on our number board, number line, if I jump 1 position to the left, I'll land on -5. But if I went 1 position to the right, I would have to add 1, and that would have me on -3. So very careful here to say -1, which means x. Therefore, x is equal to 1. Right? Let's look at number F. Number F says 2y plus 1 equals 5. So 2y, y is just another letter of the alphabet. It's just another variable. Let me just quickly touch base on those terminologies that we worked on in our assignments. So what is this 2 right here? If I look at my variable is y. A variable, some of you had some very fancy definitions, which I'm sure you got off Google or Wikipedia or something. But all I needed to know is that a variable is a letter of the alphabet that changes. Its value always changes. But what is this 2? This 2 in front of the letter is a coefficient. So the coefficient can never contain x or y or a or b. Coefficient is just that value. Whether it be positive here, there's also negative values, but then we have this +1. That +1 would be our constant. So that's just your numerical value that does not change. It's basically the opposite of the letter. Okay, but back to the equation part, we find ourselves saying 2 times something plus 1 is equal to 5. So let's just use the inverse operation. Let's take 5 minus 1, that gives me 4, and then I just divide it by 2. And I get, y, therefore, is 2. Let's test it. Does 2 times 2 plus 1 give me 5? Yes, there we go. So we're playing around the whole time. Look at number G. Minus 2x equals 8. What would my coefficient be now? My coefficient would be a -2, not just 2, a -2. Right, back to what we see. We see we have product here. Okay? Minus 2x is the same as minus 2 times x. I ask myself, minus 2 times what will give me a positive 8? Positive 8. And I know a rule called a minus times a minus is a plus. So that means that minus 2 times that something to give me a positive 8 should be a minus. And then what else? I know 2 times 4 is 8. Yep, that will be true. But I'm not writing my answer like that. I'm saying therefore x is equal to -4. Okay, right. Number or letter H. Let's see, letter H. H I'll do up here. Minus 2x is equal to -6. Again, let's just check those signs. I have a negative, I times it by something, and I end up with a negative. That means that my value for x should be a positive. 2 times what is 6? 2 times 3. So in this case, because that negative is already part of my coefficient, negative 2 times positive 3 will leave me with a negative 6. Okay. So let's quickly see if we have a look at, I just want to check number L, number N, and number P. Okay. So number L is given as x divided by 6 is equal to 2. And I ask myself, I have something, I divide it by 6, and that will give me 2. What you can also do is you can always write over your equal sign. The whole number on the right-hand side or the left-hand side can stand over 1, which then means if I have gone, you can go either way. You can say, what have I done to 1 to get 6? I've multiplied it because this is equivalent fractions. What do I do to 2? I also times it. So therefore, x is going to be 12. That's one way of doing it based on the rules of equivalent fractions. But the other way to do it is to just say, okay, something, divide that by 6 gives me 2, which means 2 times 6 will give me x, which is 12. Let's look at number n. Number n says 2 to the power of something. That's something. Now the x is in the power. 2 to the power of something is 8. But we already know, don't we? Because I drilled you with this lists. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. And what do we see here? Therefore, we can go straight to therefore x is equal to 3. And then that other one, number P. Number P, the root of x is equal to 9. Okay, here we go with our little list again. We learned square roots. Square roots are your perfect squares. So it's the opposite of saying 3 to the power of 2 is 9. Then I say square root of 9 and I get 3. 4 to the power of 2 is 16. I take the square root of that and I basically perform the inverse operation. I am interested in this one right here. That's what I'm interested in. Oh, sorry, no. Let's go further. I've looked at the wrong one. So let's go. 6 squared, 36. Root of 36 is 6. 7 squared is 49. Root of 49 is 7. Let's go one more. 8 squared is 64. 9 squared is 81. Oh, there I go. Root of 81 is 9. That's what I'm looking for right here. I want x to be 81. Why? Because the square root of 81 gives me 9.